Hey there, Precalc. It's time to talk about some trig identities. So we're moving into chapter 5. We're going to be solving equations, of course, but before we solve equations, we have to know our identities. So the first thing I'm actually going to do is I'm going to start over here on our coordinate grid and just remind us of a few things here, which is that we have a right triangle that we create here, right? We have angle theta in standard position. Our side lengths are x and y. We also have our radius here. And of course, it's a right triangle. We could talk about cool different things here. We could talk about like x squared plus y squared equals r squared, which we'll get to in a little bit. And we, of course, know all of our trig here, which is that sine is equal to y over r, cosine is x over r. So let's go ahead and let's just write some of our basics down, right? So we know that we have sine of theta is equal to y over r. We also know that cosine of theta is equal to x over r. And we know that tangent of theta is equal to y over x. Just the things that we've been kind of talking about since the start of the semester, and all the basic trig things that we do. And we also know that, of course, in our unit circle, which we kind of prove is that, hey, this r value is 1, and that's why we're able to say that cosine of theta is equal to x and sine of theta is equal to y in that unit circle, right? Okay, so breaking these down just a little bit further, we, of course, have our reciprocals. So we have that sine of theta is equal to 1 over, actually I guess we should start in the other direction. Let's start with our cosecant. So we have cosecant of theta is equal to 1 over sine of theta, and we can then also say that sine of theta is equal to 1 over cosecant of theta. Either one of those. Same thing with our cosine. So we have secant of theta is equal to 1 over cosine of theta, and then therefore cosine of theta is equal to 1 over secant of theta. And then we also have our cotangent, which is equal to 1 over our tangent, and that tangent of theta is equal to 1 over cotangent of theta. All right, so just all the basics again. We're just writing them all down so that we have one place to refer to. And then the last little bit here are things that we do know, but I want to kind of point out, of course, is that we have this ability of saying, right, that our tangent is equal to our y over x, and we know that our y value is sine and our x value is cosine. So we can then therefore say that we have tangent of theta is equal to our sine of theta over cosine of theta. And of course, cotangent is the reciprocal of that. Therefore, cotangent is equal to cosine of theta over sine of theta. So just a little like heads up, some extra ones that we have seen before, but I wanted to remind ourselves of kind of these little special things in here. So those are all just like kind of our basic trig functions and trig identities that we work with when we're kind of rewriting a few things that we might need to rewrite. So one thing that we have not seen before is that you can square your trig functions. And I'm saying square because that's what we're going to do today. But of course, if you need to, you could cube or anything in terms of your trig functions. So you can do that with anything that you need to. For example, here we're going to say sine of theta squared. Now, how we write this, and we haven't seen this before, is we actually put that little the little exponent here kind of up in the top. So we're going to say sine squared of theta, or sine squared theta. And that's how we're saying that we're squaring the whole thing. Now, just as a heads up here, right? I want to put this down here. This is not sine of theta squared. This is different, right? So not sine of squared theta, not sine, kind of cross through this guy. I have pink up there twice. So not that guy, right? So it's talking about squaring the whole thing here. So just as a heads up. And we can use that for anything that we want. We can use it for, right? We can say sine squared of theta is equal to, we can square the other side of it, right? So we could say sine squared theta is, or sine of theta is equal to 1 over cosine. Then we can say sine squared theta equals 1 over cosecant of theta. I think I said that backwards before. So just to kind of refresh is that we have sine of theta, of course, is equal to 1 over cosecant of theta. Therefore, sine squared theta is equal to 1 over cosecant squared of theta. So you can go ahead, you can square it and still use your trig identities and set them equal to. One more example here is like, hey, tangent squared of theta. Well, we know that tangent is equal to sine over cosine. So we have sine squared theta over cosine squared theta. So as long as you square it and you square everything else, again, it's algebra, as long as you're doing it to the whole equation, you're okay to do it. So just as a heads up there. All right, let's jump into some of these Pythagorean trig identities. Okay, hopefully I gave myself enough room up here. So this is the part where I said, hey, we're going to use this, right? We're going to use the idea that we have a right triangle here. Therefore, we can say our two sides squared, add them together is equal to our radius squared, right? X squared plus y squared equals radius squared. So that's actually where we're going to go ahead and start with this, is that we are going to state that x squared plus y squared is equal to r squared. Just the basic Pythagorean theorem. And then from here, we're going to solve either for x, y, or r. For example here, let's divide everything by r squared. So the reason that we're doing this is because we know that r squared over r squared is going to go ahead and that's going to be equal to 1. That's nice and easy. Well, we also know here that we have x squared over r squared, and from our basic identities we know that x over r is equal to cosine, and we know that y over r is equal to sine. So, and these are squared, therefore that we can say we have cosine squared theta plus sine squared theta is equal to 1. And I'm actually going to go ahead and erase this and write this a little bit neater because it is something that we are going to come back to a lot, is that we have cosine plus sine squared theta is equal to 1. So go ahead, star it, box it, do something here to remind yourself that this is one of your basic trig identities, and you're going to be coming back to this guy a lot, that we have this kind of Pythagorean theorem here. All right, let's start again with that idea of that x squared plus y squared is equal to r squared. But now dividing everything by r squared, we're going to go ahead and divide it by x squared. So we now have everything over x squared. And once again, this x squared over x squared becomes 1. And then we're going to rewrite our other functions based on our relationship of x over y. Well, we know that, y over x or r over x. So y over x, of course, is tangent. So we're now going to have tangent squared theta. And r over x is secant, so secant squared of theta. And there's one more trig identity for us to use, is that we know that 1 plus a tangent squared theta is equal to secant squared theta. And the last one that we are all going to go ahead and use, and again we're starting off with this x squared plus y squared is equal to r squared. Now we're dividing everything by y squared, And again, finding that this goes ahead and this is just 1. X over y is going to be cotangent. So we have totangent squared theta plus 1 equals to r over y is cosecant theta. And one more trig identity for us to kind of store and use is that we now have cotangent of theta plus 1 is equal to cosecant. So we're going to be using all of these when we kind of rewrite some things. It's a good paper to go ahead and kind of review and put a little bit things into our head. As always, you can kind of, if need to, you can derive all of these trig identities down here. But it's a good idea to kind of put these in our head, or we're going to be using them, so we need to start kind of thinking about memorizing these, especially this one. We need to know that cosine squared of theta plus sine squared of theta is equal to 1. All right, so let's go ahead and let's start with some examples here. So let's just start with the basics. You might have something like, hey, let's go ahead and rewrite this, like 1 over cotangent of x. Well, 1 over cotangent of x we know is tangent of x, right? So we're just kind of rewriting a few things. Let's try number 2 here. Let's do sine squared x minus 1. All right, well, these are the kind of things that we might need to kind of rewrite over here in terms of looking at our sine and cosine, right? So if we're thinking of sine squared x minus 1, what ended up happening here is, right, we would minus 1 on this side, we'd minus cosine squared on the other side. So this is actually equal to negative cosine squared x. And again, if you need to, you can always kind of rewrite your theorem up here. Oops. You can always kind of rewrite your theorem and move some things around until you get what you need to from the beginning. And one more. Let's try tangent squared theta minus secant squared theta. All right, well, again, looking kind of up here is that if we kind of rewrote some things here, so if we had tangent minus secant, we'd end up minusing 1 on the other side. So this is equal to, oops, theta, this is equal to negative 1. All right, so as you can see, we can kind of rewrite a few things. Actually, for room up here, I'm going to go ahead and move this over to the other side. Rewrite a few things and kind of get to the part that you need to. All right, so a lot of our examples and kind of instructions in terms of trig identities are going to be write as one trig expression or number. And what that means is you're going to go ahead, they're trying to get you down to like something like sine squared theta or cotangent squared theta or 1 or, right? You're just trying to get down to one trig expression on this. So let's start with example 4 here and kind of rewrite some things. So we have cosecant of x minus cosine x times cotangent x. All right, and these are really similar, I would say, like kind of the same thing as exponent rules, is that you just kind of need to move some things around until you find one that kind of works together and kind of work with it. You don't quite know where to start, but you can start to rewrite some things. And what I mean by that is we can actually go ahead, we can rewrite our cosecant of x, we can rewrite it as sine, and we can also rewrite our cotangent of x. So we're going to rewrite these functions. So we know that this is going to be 1 over sine of x minus cosine x over 1 times cotangent is equal to cosine x over sine x. Okay, now we can see that this is 1 over sine x minus cosine squared x over sine x. Now, this is really nice that I have two common denominators. Not always do you have common denominators, but we do have a common denominator of sine. So we now have 1 minus cosine squared x over sine x. All right, we're almost there. We can start to see it. I'm going to tell you right now, your Pythagorean theorem is going to come up a lot. And we know that 1 minus cosine x squared is also equal to sine squared x, right? So using our Pythagorean theorem from up here, minus cosine on both sides, is that we have sine squared x over sine x. Cancel out one sine on the top and the bottom, meaning that we now have sine x. And we just did it. We got down to one trig function here. And that's all of our goal, right? So it's kind of similar to these exponent rules that we've worked with in the past, or maybe like some proofs that you might have where you just kind of have to rewrite and kind of work with some things in order to get it around to the position that you'd like it for. All right, let's try one more here. So we have sine squared of theta plus sine squared theta times tangent squared theta. Well, there's always factoring that we have. We can probably see here that both of these have a sine squared theta, so we can go ahead and we can factor that out. So we now have sine squared theta times 1 plus tangent squared of theta. All right, tangent squared of theta, going back up to some trig identities if you need to, right? So we have 1 plus tangent squared of theta. That's equal to our secant squared of theta. So we now have sine squared theta times secant squared theta. Okay, I have to get kind of our sines and our secants into the same type of realm here. So let's do sine squared theta. We're just going to put it over 1 to show ourselves that secant of theta is 1 over cosine. So 1 over cosine squared theta, sine squared theta over cosine squared theta is equal to tangent squared theta. And we got down to that final trig function, just one trig function. It's okay if it's squared, but we're trying to write it as a simple function. So again, just kind of moving some things around. There's some different ways that you could do it. Maybe you didn't quite see it in that direction, but just kind of moving around some expressions that we're working with. All right, last example that we're going to go ahead and do together here. So example 3 down here. So we have secant of theta times sine of theta over tangent of theta. And this is a great example to show you that it can be done in many different ways. You may or may not see the same way that I do. So I know that secant is equal to 1 over cosine of theta. I'm also going to go ahead, I'm going to break up our sine and our tangent. And you may or may not have done this. You might have changed tangent into sine over cosine and started canceling out from there. We now see that we have a sine of theta over cosine of theta times 1 over tangent of theta. So what I just did there is I just kind of combined these two. And now I know that sine over cosine is tangent of theta times 1 over tangent of theta. Well, those two things are going to cancel out, leaving us just with 1. All right, so and again, a lot of people do this in a different direction. Like I said, is that you might have started here and changing tangent into sine over cosine, canceling out maybe our sines. So there's different ways that you can approach these. You just are kind of moving around until you get to either one number or one trig function.